could I maybe say, what are some things you guys are hoping to find out from this? What are you guys hoping for? What would, like, what's the reason you're here? And like, if this meeting ends and you go, that I got what I wanted out of that meeting, what would make this meeting, what would make it a success? What are you looking to hear?
What is it?
What is it? Yeah. Anything else?
Basic application.
Yep.
In classrooms.
How the teachers will benefit.
Okay.
How the students benefit from it.
Cool.
What we should say to schools.
What we should say? Yeah. Anything else? No. Okay. Cool. We can start there. It's quite general, but I'll do my best. Okay. So basically, we want to get more interactive and more mathsy for our high school kids, right, and teachers, because that's what they want to do now. Historically, in high schools, something that takes up a lot of time and for some reason is less interactive is all kinds of graphing. So mathematical graphing. And you kind of miss out on some stuff because functions and graphs. So basically, open that up. Functions and graphs are part of they're part of my favorite part of maths, right? It's one of the most exciting parts because I could imagine the moving of graphs based on different parameters in my head, but because everyone can't imagine them, it's hard to explain, right? So stuff like for example, this graph over here is not moving, right? It's the movement and the dynamism that's really going to sell this, right? Because that's what's going to make kids understand stuff. So, for example, if you just have the equation, so there's the standard straight line equation, y equals x. I don't know if anyone else here has seen. Basically, just a quick maths thing, right? This is I'm not sure how much everybody knows, so just for my own sake, right? The vertical number line is y, and the horizontal number line is x, right? So if y equals x, right, it means that every time, whatever x equals, y equals, and that's the point. So when x is 1, y is 1, and that's the point. When x is 2, y is 2, and that's the point. And eventually you join all those points together, it makes a line, right? So for example, if y equals 2x, right, because you can change this so easily, if y equals 2x, that line is going to become a bit steeper because y is always going to be double what the x is, right? So when x is 1, y is 2, and so on. And now we've got a steeper line, and when it equals 3, it's going to be even steeper, right? Now, this is what math teachers do in real life. They'll actually draw this line. They won't have it a computer that draws it, right? And even right now, you guys are pretty bored because you're not seeing it move, right? But the good news is, if I go and change that 3 into something like A, right? We don't know what A is, but it's going to automatically suggest to me to add a slider. Right, so now A goes between -10 and 10. Now instead of me showing you, okay, now we start again, 1, 2, 3, we could have that slider over there, and if I do this, you actually get what I'm talking about. See? And you can make it spin around. So a teacher now can actually, or a student can actually do that and not have to imagine it moving. It moves on its own, right? And you can even, you can animate that. Right. And so, sort of in 30 seconds, like if I did this at the beginning, it's sort of much easier for you to understand what's happening than me saying this is 1 and 2 and 3. Right. And it actually animates what's happening right over there, like that. Similarly, right, similar stuff like, for example, so really what Desmos does is, okay, take a break. Really what Desmos does is it actually brings the maths to life, right? It actually brings sort of control to the student and control to the teacher so that they can move stuff around and mess with the content and actually be empowered, right? So for example, when before a teacher might say, okay, let's say we've got y equals x minus 2 times x plus 1. And, ooh, sorry, I forgot the equals. Right? And it draws that, that's the graph. And that's where the conversation would end. It would end there. They'd go, okay, everyone, if you write that down, that's the graph, right? Because there's no variation when you draw on the board. There's no variation and it sucks, right? And they're doing their best after going, now if that 2 was a 1, then it would be here, you know, and if that 1 was a 3, then it would be here, and so on, right? And they're really trying to do that. But again, if we introduce that variation, right? If we said, let's say this is x minus a, right? Add a slider, and this was x minus b, right? Add a slider. Now we can say, right, so if I just move this, right, so the cool thing is you can say, let's just make this go in units, right? So if I click on that, sorry, this computer's a bit funky. I can say I just want b to be between minus 10 and 10, minus 10 and 10, sorry, what are you doing? And 10, and I said I wanted to only step up in units of 1. Let's click off that. And now that's only going to go in units of 1, and I want to do the same thing here. Minus 10 and 10 and 1. So now, I wish my computer was working.
Use your genes. Do it on your.
Use my genes?
Like, no, see the mouse?
Yeah.
It might be easier there. Right?
Okay.
There's a touch screen. So we
Well,
can
there's
use
a,
that
yeah.
screen.
So,
Oh, that's a different keyboard. It used to have a little.
so now I can actually change that value for A and B, and you can actually see what, like,
That's a good idea.
no one could actually see that happening. They actually hopped over like that unless you did this. Right? Now, you're all sitting here going, this is pretty shit and boring, right? But this is the stuff math teachers and students love. I love this, right? So the fact that you control this kind of thing is incredible, right? And what's nice about this
Notepad
is,
if you want. Notepad.
I got a mouse pad.
Use the mouse pad.
you guys are a bunch of legends. Oh, we have the technology. Okay. So the fact that you can move this, right? Now, right, so who can tell me what that minus 2 and that minus 6 is? How's that showing up on the graph?
Where is the x-axis?
Yeah. Where it hits the x-axis, right? Now, the fact that you can change where it hits the x-axis graphically, every time you show this to a teacher, I promise you, they'll say, oh, I just did that in class today, it was so hard because I had to redraw and everything, all that kind of stuff, right? You can add another one, so let's just keep going, right? Let's bring back all old y equals, c times x. Yeah, suggests to me add a slider. And I've got that line there, and you can talk about them at the same time. Where they're cut and all that kind of thing. It's great also for if you did something like, you just type what you're thinking. So you can say y equals sine x.
What I was thinking.
Oh, that's what I was thinking. Right? But
I was just thinking why.
But normally, like with these kind of things, you have to type y equals sine brackets and just whereas this actually it's just so human, intuitive, normal language.
So Matt, you're passionate about this stuff. You're a mathematician. You get it. Most of us aren't mathematicians. We're passionate about what we do, but we don't get it.
Okay.
So what sort of things how could we introduce this concept to a teacher if we're talking to them?
Okay. So
Open their eyes to what
Yeah. I mean, we're assuming that they'll get what you're talking about.
Yeah.
They'll know that. If they're a maths teacher,
Yeah.
if they're an out-of-field maths teacher, they won't. If they're a geography teacher teaching them maths, doing a cover, they won't have a clue. So, I mean, a lot of teachers are like that in secondary, unfortunately.
Yeah.
So what sort of things can we say?